right, like he said, hi, I'm Kali Sip. I am a recent graduate of Northland College, Geosciences, and I am an intern at the Cable Natural History Museum for the summer as the Geology intern. And I'm going to be teaching you guys about the esker that is here on this property. And one of the things we need to learn about eskers is that they are a glacial landform. So we have to learn about the glacier history of Wisconsin. So last glacial maximum was around 26,000 years ago. And during this point, we had this huge glob of ice all over northern part of North America. And the number one thing about glaciers is that they flow. They are constantly flowing when they are precipitating ice and snow up glacier. But after a while, glaciers will slowly creep to a stop, and they will stop their spreading. But it is important because these glaciers will leave all sorts of material in their wake. And this material is called glacial till. And this glacial till comes from up glacier. So glaciers will scrape along bedrock, will pick up all sorts of chunks, bits, and pieces, and incorporate it into the glacier. This material is important because that material acts as a saw in itself to abrade off more material. And on bedrock features where there might be like a hummock or a hill in it, there can be a lot of plucking of this material on the lee side of the glacier. And abrasion on the underside of it can polish stone faces. I've seen beautifully glacially polished granite up towards Melon, and you can see the streak marks that indicate where the glacier was flowing, the direction that the glacier was flowing. Just kind of like how if you pour a pancake batter into a pan, a glacier flows much like that in those big old lobes. And there are a lot of glacial landforms that come from this material, this glacial till. And one of the better ones known in Wisconsin are the kettle lakes. So big blocks of ice will get buried under all sorts of glacial material. So sand, silt, clays, sometimes huge boulders. I've seen glacial erratics, so large rocks that are not the size of the other material around it, that are the size of houses. And these are all transported by the glacier. And these pieces are transported for up to thousands of kilometers. I've seen rocks from the Canadian Shield down by Wapaka, sometimes even further down south, depending on where you are in the state. But these kettle lakes have these huge blocks of ice, and then all of the material is like surrounding the blocks of ice, and the blocks of ice melt out. And then suddenly you get these divots in the landscape. And these divots will then fill with groundwater, and boom, they become glacial kettle lakes. So a lot of the lakes here in northern Wisconsin are these glacial kettle lakes. Lake Namagakin up by Cable is a kettle moraine lake terrain, and a complex kettle lake where multiple large blocks of ice was buried in all of this glacial till material, melted out, lake filled up, boom. But the one we're interested in today is called an esker. And eskers form when a glacier dies. So I mentioned glaciers flow. When glaciers flow, the material is constantly being paved over, flattened, etc. But when a glacier dies, that all stops. The glacier just sits there, and like an ice cube sitting on a table on a hot summer day, it just melts out. And whatever material that glacier is transported for however many tens, hundreds, or thousands of miles melts out with it. And with that meltwater will want to find the path of least resistance off of the glacier. And that water will drill down under the glacier. So that is called a moulin, where the water kind of drains off of the glacier, just goes right through the glacier. And then a cave is formed where all that material, or where a good portion of that material that is melting out of the glacier, is deposited at the bottom. But of course that meltwater still has to go somewhere. So it's gonna find a way out somehow. And a subglacial channel river starts to form under the glacier. But here's the thing. Water wants to find the path of least resistance at all times. It doesn't want to carry all of the material it has with it. Instead of, gouging out a river channel, which takes a lot of work, when your water already is loaded with sediments that are melting out from the glacier, you now have it deposited on the underside of the glacier as the water eats up into the glacier itself. Because it's easier to melt more of the glacier than it is to just move not only the material that the water is already carrying, but eating away a new river channel. So eventually you'll get this huge long line of material built up over time as the water moves on, carrying sand, silt, sometimes boulders in this subglacial channel until it flows out. And then the glacier continues melting back, and slowly this ridge of material that has been deposited by this subglacial channel is revealed, until finally the whole glacier is gone, and boom, you're just left with this weird ridge of glacial material that is the esker. And I think the best way to learn about an esker is to go see it. So let's go see the esker!
All right.
And I thought I would also show this. This is a cobble of rock that was transported probably up by ironwood. This is a banded iron formation that has been transported from that area all the way down here to here in this location. And it's a good example to show, like, if you know what certain rocks look like up glacier, you can tell, like, oh, this is where the glacier flowed, and you know that at some point that the glacier just scooped it up, picked it up, dropped it here. Welcome to the top ridge of the esker. So you might have noticed on both sides it drops off pretty quickly. That's the ridge that would have been making the spine of the esker, and then water would have flown off depending on the sediment load. So oftentimes on the edges of eskers, along the sides of them, you will get vernal pools or wetlands. This is because the water that flows off the edge of the esker and is able to get further under the ice is carrying clays. And these clays lay down a thin layer that then acts as kind of like a bowl on the edge of the esker to catch any water. So during the springtime, you get these vernal pools that form along the edge of the esker, or you get these wetlands. And we kind of have that along here and over on this side here. But right up here is an interesting feature. The esker suddenly ends. We'll see that down there. A little easier, a little better. And then you go a little further, and then the esker starts up again. Now, that's an interesting feature. Why would that happen? Well, an event here happened called a Geology, pardon my Icelandic. This event happened because of a proglacial lake had built up behind the esker, and then water built up, and then the dam broke. The dam being the Esker. So now down through where the Esker is no longer there, you have a small stream that has slowly been stripping away more and more of the sides of the Esker. So when we go down through here, take note of the missing portion of the Esker and realize that this was a glacial dam that had broke in that event, in the Geology. And interestingly, a very similar thing happened at Wisconsin Dells. Glacial Lake Wisconsin was dammed for a long time, and all throughout the Central Sands area, that was Glacial Lake Wisconsin. But then an ice dam broke, and in the span of 2 to 3 days, scientists estimate, all of Glacial Lake Wisconsin drained. And it drained through the Wisconsin River, and specifically through the Dells. The Dells were formed by all of this water rushing out in that 2 to 3 day period. And now you can go down in a duck and look at the Dells. Yeah.
How big was that Lake Wisconsin?
It covered a big portion of Wisconsin. The whole Central Sands
really?
area of Wisconsin was the bottom of Glacial Lake Wisconsin. So that's
It was big.
Yeah, it was a big lake. Yeah. So when we go down, you can take a look at that. And another thing I would like to note is that Eskers are actually a natural resource in themselves. The material in an Esker can be mined out for great road building material. So all of the material in an Esker is very not well sorted. It's not well sorted. So you have pebbles, sand, silt, clay, larger cobbles, boulder-sized materials, and all of that constitutes up the Esker. And then people will come along, mine that out, and use that as road bedding. And it's very, very good road bedding. Because think of marbles sliding over one another that are all the same size. But then you add marbles that are smaller sizes, and they fill in the cracks and other crevices in between the other larger marbles, creating a locking matrix that is not as susceptible to slippage. So that is why Eskers are often mined out. And there are entire Eskers in Wisconsin that have been completely removed from the landscape and used for road building. So Eskers in some locations are an endangered resource. So having one that's basically intact is pretty darn neat.
I have a question.
Yeah.
So is it just this very steep sides? I mean, a lot of us have ridges on our land. What's the difference? How do you tell if your ridge is an Esker?
So that's when you get a topographic map and you take a look at what's going on. Eskers usually are really sinuous, like a stream.
Okay.
They're basically, that's why I mentioned at the beginning, they look like a reverse stream when you look at it on a topographic map. You might think, oh, that might be a river valley, but then you look at the levels on the topographic map and you're like, oh,
They go up.
they go up. So looking for like a sinuous river pattern on a map is a good indicator. And then, as I mentioned before, another good indicator is looking for vernal ponds or swamplands alongside the edge of the Esker. And those swamplands or vernal ponds usually don't extend super far out away from the Esker. Usually they're just right next to it.
Okay. Thank you.
Yeah. Any other questions, comments, outbursts? Yeah.
What about the surface water close to the Esker? It occurs to me, depending upon the material in here, this might be a great gatherer and transporter of groundwater to surface water. True or untrue?
I'm not sure.
Because I'm thinking of there's that huge Esker just east of Telemark.
Yeah.
And that's where you get Spring Creek, 5 Mile Creek, the Namakogan River, and the
Yeah.
Cap Creek all become trout water at that point. That indicates tremendous amounts of groundwater coming through the system. What's the role of the Esker?
I am unsure. I don't know the answer to that. I wish I
I'm putting my money on it has a major role in consolidating and transporting groundwater at that point.
I don't know, because groundwater tends to fill up any pores and just flows through glacial
Yeah, and there's
material.
that's all full in this, right?
Yeah.
Yeah.
Maybe it acts as a divide in some
Maybe
areas.
it sheds it off the surface.
Well, yeah, it definitely sheds it off. It's that groundwater's not staying up here, that's for sure.
Yeah.
It's flowing off the edges.
Plus, as you say, there are these little areas in there when it was formed that are basically open space. But by now that they're all filled up with fines, right? Or not?
Maybe not at the top. That might be transported down off to the sides in those vernal
Because
pool
say
areas.
if there were several of those big crevices there and they're filled with small gravel and sand, that would transport water like crazy.
Yeah.
Sometimes the water comes in the top here, and if it's going through the sand and gravel, it comes out the bottom as a spring.
Yeah.
Because the groundwater's higher here
Yeah.
than there. I mean, I've seen it come out of hillsides.
Yeah. I mean,
Because the
Really
temperature of that creek down there says incredible amount of groundwater. in
Yeah.
The stream is spring fed further up
Yeah.
from
Yeah.
Eskers up there.
there. Okay, further up?
Yeah. So I mean, if you want to go look at it,
Okay.
I can show you where
Okay.
some of the
yeah.
springs are.
If the cold water guy had come on time today, we would talk about the trout stream.
Yeah. I don't know much about the groundwater in relation to Eskers, unfortunately. Yeah.
Is this the average width of an esker?
Eskers can come in all sorts of sizes. Some eskers are huge, like miles long. The longest one in Wisconsin is actually a bike trail. The ridge of it is the bike trail, and it makes for wonderful mountain biking because the material stays in place.
Where's that at?
I'm unsure. I just know that exists.
Is that part of the kettle moraine down like?
I don't think. No, I think it's up here.
Okay.
I know those trails.
I mean, there's the ice age trail.
I don't know, the game you did?
Yeah, but Ice Age Trail is more along the terminal moraine of Wisconsin.